carbon. Would that be like what? 1/12. So, so if I look at that, what is the mass number, what is the mass for carbon on your periodic table? 12. What is the mass of hydrogen? 1. So it's 1, it's 1/12. So basically everything, what they really did is they kind of took carbon first, and then they built everything else kind of around that number. So, atomic mass of an element is what's actually on your periodic table. The number that is not rounded is your atomic mass. And it is the weighted average mass of all isotopes of that element. So if I look at chlorine in particular, I have chlorine 15, I have chlorine 35, and I have chlorine 37. Those are the two isotopes. Notice that the actual mass is 34.969. Percent abundance is around 76%. So there's more of the 35s than there are the 37s. Therefore, if you look at chlorine on your periodic table, it's closer to 35 than it is 37, because more isotopes have that. To find your atomic mass, and we will practice this a little bit, the easy way I remember it is you take mass times abundance equals, and then once you've done that for all of your isotopes, you total them together. And we'll do some examples. Abundance is not a percent, it will be a decimal number. So to calculate atomic mass, you take mass times abundance, and then you do that for however many isotopes you have, and then you add that total together.
So like you change the percentage to a decimal?
You change the percentage to a decimal.
So in that diagram there'd be two that we would...
Yep, you would have two numbers. So my one number is 26.499. My other number is 8.9531. I add those two numbers together. If I had 3 isotopes, I would add 3 numbers together. And we'll do an example yet of that. So I'm going to skip that for now. And then here's your review. Here's the end. So make sure that you know the difference between atomic number, mass number, atomic mass. Isotope has a different number of neutrons. The protons are always the same. And then we'll do some of our math practice. So if we go to I want to go to page 121 is where you have your practice problems. So there, it gives me a table, and I have X6, so here's one isotope of an element, and I have X7. You take mass times abundance. So the mass of the first one is 6.015. The mass of my second one is 7.016. And I'm going to take that times the percentage as a decimal. So my percentage is 7.59%. How do I change that to a decimal?
Move it to the
left 2 places, or divide by 100. Left 2 places, or divide by 100. So 7.59%. This one is 92.41%. So I move it to the left 2, or divide by 100. Then you multiply those out. So I take my mass times my abundance. And did they do that for me? They did. So I get 0.456. And for this one, I get 6.016. 6.483. And then what do I do with those two numbers? Add them together. So I take this plus this gives me 6.939.
Yep.
That would be my atomic mass.
So how do you find your abundance? Is that just going to be in the problem?
It will have to be given to you. I don't expect you to know. For example, if you Google isotopes of different elements, some elements might have like 6, 8 different isotopes. I will not have you calculate that many. For example, tin. I think tin has a bunch. I won't have you do tin. I might have you do carbon. Carbon has 3. Hydrogen has 3. Hydrogen's a very common. There's hydrogen 1, hydrogen 2, hydrogen 3. So to find the atomic mass, you take mass times abundance and make sure that you change your percentage to a decimal. And then the only other practice problems are on page 118, but we kind of did that already. So very quickly, let's just do one more of those. Let's do a bigger number. Let's find copper. Find copper on your periodic table. What is its symbol?
Cu.
Cu. What is its atomic mass?
64.
64.
And the atomic mass will always go on the top.
Atomic mass will always go on the top. What is the atomic number?
29.
29. And the reason, I don't know if this is the reason scientists set it up that way, but to me it makes sense because it's easier to subtract when I have mass on top of my atomic number. So the 29 tells me I have 29, what? Protons, 29 electrons, and how many neutrons do I have? 35. 14, 6, 5. You have 35 neutrons. Calculator. I did not say. So all of my students, both sites, test. You can use a calculator. I don't want you to make a small error just because you subtracted something wrong. Okay, so I have an element that has 5 electrons. What element is it? Boron. It is boron. If it has 5 electrons, it has 5 protons. That should be its atomic number. What element has an atomic mass of 24? Magnesium. Okay. So if you can figure out how to calculate and how to use those, you should be okay.